All right, let's go ahead and take a look at now the concepts of functions here. So let's look at concepts of functions in algebra. All right. So what's a function basically, right? A function is basically a relationship between two sets. So let me say a function relates two sets together. So relates two sets. Relates two sets together. Now, what does that mean, first of all? Well, it relates two sets in a very specific way. Let me give you an example here, right? So, suppose I have a function that relates the score, your exam score, for example, to the grade you get, right? So let's go ahead and take a look at that. So the first set is going to be the exam score. So let's say I have exam scores in here. So set 1 will be the exam scores. So test scores. All right. So let's say the first exam score is 75. Next one is 82. Next one is 91. Followed by let's make it 73, for example. All right. And so I'm gonna map these numbers in the first set to letter grades in the second set. So set 2 will be the letter grades. Obviously, we have A, B, C, D, and F, which I'm leaving off here, obviously, right? So let's go ahead and call these grades. So a function can relate test scores to grades. So, well, basically then, if I follow the standard scale, we're going to map 75 to what letter grade? To letter what? Letter C, right? 82 is a B, all right? And 91 is an A, obviously, all right? And 73 is also going to be a C, all right? So basically, think of my function, and we use the letter F for function here typically. My function is going to map the test scores to the letter grades here, right? In other words, I put this into my computer. I put in the test scores in my computer. My computer spits out these letter grades. So the first set then are called the inputs. So these are the inputs, right? The grades produced by the computer are my outputs. All right. Now, in function terminology, excuse me, the inputs we call the set of inputs called the domain set. Domain. All right. The outputs we call the range. All right. In other words, I enter the domain, the computer spits out the range. All right. But the relationship is very specific. So here's what I mean by that. So in other words, for a function, it's okay to have two different test scores to the same letter grade, 75, 73, both a C grade. However, it makes no sense to say 75 is a C and 75 is also a B. Right? That makes no sense at all. So therefore, for a function, basically, you have to have only one mapping to the range for each domain element. All right? So let me say that a function relates every domain element to exactly one range element. Again, what does that mean? It means that to be a function, we have to what? We have to take each of these domain elements, right? Each of these test scores into exactly one letter grade, right? Again, it's okay for two different test scores to have the same grade, but it's not okay for one test score to have two different grades. Again, it makes no sense to say 75 is a C and 75 is also a B. That makes no sense at all. So again, it's not okay for what? For a domain element to be mapped to two different ranges. But it's okay for two different domains to go to the same range. That's okay for a function. Again, a function relates every domain element to exactly one range element. That's really the key concept, exactly one range element. All right. So what's another example of this? Well, let me go ahead and clear out the screen. Let me take a look at this relationship. Let's go ahead and relate, for example, car. Let's take a look at car makers to car models. All right. So is this relationship a function? Let's say I have a function that relates car makers such as what, Honda, Toyota, Chevy, right, for example, right, and so on, to the car models here, right? Is this a function? Well, again, car makers though can make multiple models. Can we see that? So for example, let's take a Toyota, and that's pretty famous car maker, right? Toyota makes what? Obviously the Corolla and the Prius, for example, right? So therefore, it takes the domain to what? Two different ranges here, right? So D for domain, R for range, right? So is this going to be a function? Well, again, for a function, it's not okay for the domain to go to two different ranges, right? So that's not okay. So this is not a function. So a relationship between car makers in domain to car models in the range is not a function. However, if I were to switch it around, then it would be a function. So let's go and switch it around. Let's say car models for the domain, right? We're mapping car models to what? Car makers, car manufacturers, that is, right? So is this a function? Then yes, it is, right? The answer is yes, right? So for example, we can say that, for example, what's a car model here? How about I'll use Honda, since I don't know too much about cars here, right? So let's say, car models from Honda include what? Include the Civic and the Accord, for example, right? And yes, they both can be mapped to what? Mapped to Honda. All right. Again, it's okay. Again, this is the domain. This is the range. Again, is it okay for two different domains to go to one range? Yes, it is. That's okay for a function. Remember, for a function, it's okay to have different domains go to the same range. But it's not okay for one domain to go to two different ranges. That's not okay. So this is not a function from car makers mapped to car models. But if car models are mapped to car makers, then it would be a function. Yes. All right. But anyways, keep that in mind. So if I were to give you a graph of some function here, let's go ahead and clear out the screen here. Well, actually, before we get to the graph, let's take a look at function notation. Yeah, let's look at function notation. All right, so I mentioned the letter F for function, right? So typically, we'll write something like this. F parentheses x equal to, let me give you a specific function here, right? F parentheses x equal to, let's say, x squared plus x minus 6, for example. All right? So F parentheses x, how do we read this in English? Well, we don't read it that way. We read that as F of x. Okay, so F of x is equal to x squared plus x minus 6. Now, keep in mind, this parentheses does not mean multiplication. This is function notation. In other words, we're saying that this function is defined in terms of x. So therefore, it's defined as what? X squared plus x minus 6, for example. All right? So this function is in terms of x. So my input or my domain is the x. All right? My range is the y, or the function value. So this is the domain. The range. Excuse me, sorry about that. That's the range. Okay? So x squared plus x minus 6 is the range. In other words, if I give you a specific x, or a specific domain element, can you find the relationship of it to the range? Well, we can by simply plugging in. In other words, if I say, given this function, f of x equal to x squared plus x minus 6, let's go ahead and find, for example, f of 4. Right, f of 4. What does that mean? That means what? 4 is the domain. All right. Then let's go ahead and find the range element, or the y value, for when the domain is 4, when x is equal to 4. Right? Let's find the function value. In other words, function value, f for function value. All right. So again, all we do to find that is simply plug it in, plug the 4 in for the x. So f of 4 is equal to 4 squared, right? Plug it in for x, plus 4 minus 6. 16 plus 4 minus 6, or what? 20 minus 6, 14. So this is the range value that is associated with 4 in the domain. In other words, my function f will map 4 in the domain to what? 14 in the range. All right? Again, all this is nothing more than plugging numbers into a function here and working it out to get the range value. Here, let's go ahead and try another one. And let's say f of x is equal to, let's make it 3x minus 2 over 4x plus 5, for example. All right? Let's go ahead and find, I want you to find f of negative 3, f of 0, and let's find f of, let's make it negative 5/4. All right, negative 5/4. All right, so let's plug it in, basically. Right? Plug these values in for x to get their range values, right? So the domain, so in other words, domain elements are going to be what? Negative 3, 0, and negative 5/4. What will the range elements be? All right, so we have to plug it in. All right, so let's go and find f of 3, or negative 3, excuse me. Let's go and plug it in. So that's going to be 3 times negative 3 minus 2 over 4 times negative 3 plus 5, right? That's going to be negative 9 minus 2 and negative 12 plus 5. So just plug it in, work it out carefully. That's negative 11 over negative 7, or 11 sevenths. All right, so the range value is going to be 11 sevenths when the domain is going to be what? Negative 3. All right. Similarly, f of 0, well, that's not shouldn't be too bad. Plug in 0 here. So 3 times 0 minus 2, 4 times 0 plus 5. Well, again, as you can see, 3 times 0 is 0, so 0 minus 2 and 0 plus 5, so we get negative 2 over 5. Right? Negative 2/5 will be the range for the domain of 0. All right? So this function maps 0 in the domain to negative 2/5 in the range. All right? What about f of negative 5/4? A little bit more tricky, but again, just use your calculator for this if you want to, or you can do it by hand. But 3 times negative 5 over 4 minus 2 over 4 times negative 5 over 4 plus 5. All right, that's equal to what? Negative 12. I'm sorry, negative 15. Sorry about that. 15 there, 3 times 5, right? Nothing will cross cancel. Over 4, all right, minus 2. Okay, if I punch that into the calculator, before I do that though, let me go ahead and cancel the 4's out, so you get negative 5 plus 5. But anyways, we can certainly work this out in the calculus, or think of it in terms of fractions. Common denominator is 4, or 2 over 1 if you like, but anyways, this is basically what? Well, 2 over 1, 8 over 4 basically, right? So 4 is common denominator, so this will be a negative 23 over 4 on top, but most importantly, you get what? 0 on the bottom, because negative 5 plus 5 is going to be 0. So, and remember, for a fraction, you cannot divide by 0. You cannot have a 0 in the denominator. So this is undefined. Undefined. So what does that mean? That means that if the domain is negative 5/4, there is no range value for that. The function is undefined when x is equal to negative 5/4. Right? In other words, we should then be more careful when we're figuring out the domain of these types of functions, right? Because we have to make sure we're not dividing by 0, for example. Okay, more on this topic in a future section now, all right? But let me say that suppose I give you this question here and say, what value of x should be excluded from the domain? Let me say, what value of x should be excluded from domain. Okay, running out of space here. All right. Clearly, then you see that from this work right here, you can see that we can plug in any number we want except negative 5/4 because that makes the function undefined, right? So we say that x equal to negative 5/4 should be excluded. Should be excluded. Okay, sorry, I ran out of space down here, so hopefully you can see that. But again, my point is what? What value of x should be excluded from the domain for this particular function? Well, negative 5/4, because if I try to plug it in, I get 0 on the denominator, which is undefined. Right? So let's go and try another one. Let's go and give you another problem like that. Let's go and clear out the screen. Let's say g of x is equal to, let's say, x minus 5 over x plus 7, for example, right? So let's go ahead and find the following function values. Let's find g of let's make it g of 9. Let's find g of 5 as well. Okay, find these two function values, and also answer the question of earlier we had what value of x should right there. What value of x should be excluded from the domain? Excluded from domain. All right. So let's answer these two parts, if you will. Right. So well, again, just plug it in for the first part. Right. So g of 9 is going to be what? Plug in 9 for x. Right. So 9 minus 5 over 9 plus 7. That's going to be what? 4 over 16, or 1/4 if I reduce that, right? So 1/4 is the range value when the domain value is 9. Right? What about g of 0? I'm sorry, g of 5. Excuse me, g of 0. G of 5, I meant to say. Sorry about that. So that's going to be what? Plug into 5. Well, exactly, I get 0 on top, right? So 5 minus 5, 5 plus 7. So 0 over 12. Now, is that undefined? No, it's not, because 0 is in the numerator. But anytime you have 0 in the numerator and the denominator is not 0, that will always be 0. If I punch in 0 divided by 12, it'll be 0, of course. So don't say undefined here, right? It is defined. The range value is going to be 0 when the domain is 5. All right? So this g function maps 5 in the domain to 0 in the range. Right? So it is defined. Right? Getting back to our second part then, what value of x should be excluded from the domain? Well, focus on the what? Denominator, because we want to make sure that this is never equal to 0, because if it's equal to 0, then this function will be undefined, right? So what makes this thing on the bottom 0? Well, as you might guess, just set it to 0. X plus 7 equal to 0. X is equal to negative 7 if I solve this, right? So in other words, when x is negative 7, it makes x plus 7 0. It makes this function undefined. So x equals 7 should be excluded from the domain. All right? So again, all we're doing here is plugging in numbers for x to find the range of values. Plug in the domain to get the range values. All right? Now, let's work backwards. Suppose I give you a function, and I give you the, let's say I give you the, for example, the range, and ask you to find domain. Let's go and work backwards. Let's go and try this now. Let me go and clear out the screen. Let's say g of x, the function g is equal to, let's make it something simple here. What about 4x minus 2, for example, right? Let's go ahead and find c so that g of c is equal to, let's make it equal to, I don't know, how about 22 here? Let's make it 22. All right? Let's make g of c equal to 20. In other words, what domain value will be mapped to 22 in the range? So this time I'm giving you the range, right? I'm giving you the R, and you're asked to find the domain, D. All right? How do you do that? Well, that's not too hard. You're simply going to plug in the 22 this time for my function value, because this is the function value here, 22. Right? So we're going to plug it in. So in other words, we're basically solving this equation. Solve 22 equal to for what? C, because I'm plugging in C for x, right? So, or you can call it x if you want to, it's up to you, but for C minus 2. So basically, you're setting, in other words, you're setting this function to the range value, and you're solving for the domain value, in this case C. Well, that's pretty easy to solve. Add 2 to both sides. As you know, 24 is equal to 4c. So c is equal to what? 6 if you divide both sides by 4. So in other words, the domain that will map to 22 in the range is going to be 6. Right? So 6 in the domain maps to, so my function g will map what? 6 in the domain to what? 22 in the range. So so if you're given the range, just set the function equal to the range value and solve for the what? Domain value. All right? So not too hard, as you can see. Let's try one more. Let's suppose f of x is equal to negative 3x plus 8. And let's go ahead and find c again. Find c so that f of c is equal to, say, make it equal to 14, for example. All right? Again, let's go and set this function to 14 and solve. You can leave it in terms of x if you want to, but to be technically correct, you should plug in c for the x. All right? So I'm going to do that. So I'm going to say negative 3c plus 8, the function, right, is equal to what? 14. So just subtract 8 on both sides. Big deal there. So negative 3c is equal to what? 6. So if I divide both sides by negative 3, I get c is equal to what? Negative 2. Right? So my function value, to get the function value of 14, excuse me, the domain should be what? Negative 2. Right? So we sort of work backwards to get the domain, but a little bit more work for that. But to find the range, you simply plug in, once again, from earlier examples. All right, so no big deal here, just working with functions, basically plugging numbers in is what we're getting at. All right, let's take a look at then how we defined function earlier. Suppose I give you a graph. Let me give you some graph here of some function. Let's say, so here's the y-axis, here's the x-axis. Let's say I give you a graph that looks something like this here, right? Call this f of x, for example, right? So here's the graph of it. We don't know what the equation is, all right? But let's go ahead and ask you, based on this graph, is this graph a function? Is this picture representing a function? Well, remember how we defined function earlier? We have to make sure that what? There are no two ranges being mapped to by one x. In other words, we cannot have the same domain go to two different ranges. All right, so that's a pretty hard concept, but hopefully you could look back earlier and understand that. Again, it's important to what? Not have. So in other words, well, before we answer that, let me do another problem. Let's take a look at this problem. Before we answer, let's go. We'll get back to this in a moment. All right, let's go ahead and graph something like this. Here's what I mean by that. Let's graph x equal to y squared, for example. All right. So again, x is the domain, y is the range. All right. So let's make a table to graph this, x and y. All right. Now, since x is in terms of y, let me choose the x and plug it in to get the y. I mean, choose the y. Choose the y. Excuse me. Plug it in to get the x. So let's choose y to be 0. What's 0 squared? Well, that's going to be 0. Let's choose y to be 1. 1 squared is what? 1 for x. Let's choose y to be negative 1. Well, negative 1 squared is what? Also positive 1, right? Now, let's stop right here. As you can see, well, let's do a couple more, actually. 2 for, let's do one more. 2 for, let's choose 2 for y. 2 squared is what? 4. 4 for x. How about negative 2 for y? Do one more here, and it'll still be 4, right? Because negative 2 squared is positive 4 for x. But look at my mapping here. Look at the mapping here between x and y. again, x is the domain, y is the range. All right. So keep that in mind. Always keep that in mind in terms of the xy coordinate system or the rectangular coordinate system. X values are always the domain values. Y values are always going to be the range values. Okay, so keep that in mind. All right. Now, looking at this relationship, we see that look, we have the same x value, 1 namely, going to what? 2 different y values. Likewise, same x value, 4, going to two different y's again. So is this a function? Well, the answer again is going to be no, because you can't have the same domain going to two different ranges. That's not how we define a function, right? So this is not a function. But let's plot these points and see what this equation looks like in terms of its graph. All right, so let's see here. 1, 2, 3. 1, 2, 3, 4. All right, so let's plot 0, 0. So there's 0, 0. Let's plot 1, 1. Here's 1, 1. Here's 1, negative 1. 1, negative 1 is right here. All right, 4, 2. So 4 for x, 2 for y, and 4 for x, negative 2 for y. So 4, negative 2 is down here. All right, but let's connect these. Look at this graph right here between x and y. All right, again, from this graph, we see that what? We have two different what? Y values. Here's 1, here's negative 1, right? Two different y values for what? For the same x. For 1, this is 1 for x, right? For 1x. For one x value on this graph, there are two different y values. Likewise here, right? For 4 for x, right? There's two different y values. There's positive 2, and there's negative 2. All right? So again, this is not a function, not a function. Well, now we can go back to the problem here. So as you can see, if we have two different y's for one x, that's not a function. Now, there's a test, what's called the vertical line test on a graph, right? What that says is, if I draw vertical lines on the graph, all right, that cuts through a graph, if I cut through the graph more than once, that means it's not a function. If I cut through the graph only once, that means it is a function. All right? So again, look at this picture we had down here, right? If I draw vertical lines, I'm cutting through the graph how many times? 1 here, 2 here, 1 here, 2 here. So again, that means what? That means for each x, there's two different y's. That's not a function. For each domain, there's two different ranges. Again, not a function. So for the vertical line test, if you cut through the graph more than once, it's not a function. So not a function. All right? Up here, if I draw vertical lines, I'm only cutting it through at what? Once. So is this a function? Then yes, it is. By the vertical line test. By the vertical line test, it is a function. Here, let's go and clear up the screen, try another one. Let's say I give you this graph right here. All right? Let's look at the vertical line test again, right? It's not a hard concept at all, as you can see. So let's say I give you a graph like this. How about the V-shaped graph we had, right? The absolute value graph, right? All right. So let's say this is g of x. Okay. So function or not? Well, as you can see, if I draw vertical lines, do I cut through it once or more than once? As you can see, just once, right? At each x. So yes, this is a function by the vertical line test. Okay, VLT, vertical line test. All right. What about this one? All right, a circle centered at the origin. Well, is this a function? Clearly, if you draw a vertical line, you cut through it, what, more than once. So this is not a function. Not a function. Again, by the vertical line test. Alright? So again, if I draw vertical lines on the graph and I cut through the graph more than once, it's not a function. If I draw vertical lines and I cut through it once at each x, that means it is a function. Yes. Okay? So vertical line test, pretty easy concept, I think, to tell if a graph is a function or not. Right? Let's go and finish out with some problems for Blackboard here. Then let's go ahead and post the following problems as solutions to Blackboard. I'm going to clear out the screen. All right. So number 1, let's go ahead and try the following here. Let's go ahead and give you a function here. Let's say f of x. Let's say f of x equal to 5x squared plus x minus 2. And I want you to find, let's find f of negative 1, f of 4, and f of 0. Okay, find these 3 function values, just plugging it in, right? Number 2, let's say I give you a function g of x equal to, let's make it equal to 7x minus 3, and I want you to find c so that sorry about that, Sketchpad's acting up here, so that what g of c is equal to, let's make it equal to 53. Alright, so where's that? Sorry about that. Alright, so find c so that g of c is equal to what? 53. If I give you, so in other words, I'm giving you the range, 53, what is the domain that will match that? So make sure you know how to figure that out. Alright, and last but not least, let me go ahead and give you a graph here and ask you if it's a function or not. Okay, so let's go ahead and take a look at the following graph here. So okay, let's call this h of x. Okay, so let's go function or not. So yes or no question basically here to post on Blackboard. Right? Obviously use the vertical line test for that. Okay, so until next time then.